Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Okay, look at this problem. I wouldn't answer it as well because we answered one which was very similar to this. All you need to know is that the block is sliding on a rough plane and friction is not ignored. Good. And this brings us to the last topic of the day, and that is what we call static equilibrium. And here, before we go further, I'll just give you the conditions necessary for our body to move or to be in static equilibrium. Okay, the conditions necessary for a body or an object to be in equilibrium are as follows. The object has to move with a constant speed, or the forces on both sides must be equal. That is, the sum of the forces acting on the body must be equivalent to 0. And for this to happen, it means the force or the sum of the forces on both sides must be equal to each other. Good. And also, you should note that when an object is in equilibrium, it is not accelerating. That is because A is 0, and A is 0 means V is constant, or the body is at rest. Good. Now, we're not going to waste any time in solving these problems because we already have an idea of what to do. Now, this is just, a simple question that wouldn't take you 2 minutes to answer. So I wouldn't do it. We are given a box of mass 60 kilogram, which is massless, and the rope is moving in an elevator. All you need to know is that the force attached or experienced by a rope, string, or any elastic material is what we call tension. The same force is experienced by elevators, or what we call lift in our local language here. We call it lift, but then the real name or the correct name is an elevator. The force experienced by passengers in an elevator is called, tension, because the elevator operates under tension. That is why the force in that tension is called tensional force, which is abbreviated as C, as capital T. These are the things that I just explained. Good. 2 ropes. Now, when we are given 2 ropes supporting an object, for a single rope, it is always simple. For a single rope, you just have to note the direction in which the object is accelerating, or you also have to note if the object is stationary or not. Now here, for a single rope, this is what we have. Let's say this is a rope tension T, and this is a mass. If the object is at rest, what happens? If the object is at rest, it means A is 0. What other force is acting on this object? Since the object is hanging, it must have a mass, and the mass will be supported by gravity to give its weight. So we will apply Newton's law, and this gives us the sum of forces, and the object is equivalent to ma. But then the object is just hanging, or it is at rest. So it means the acceleration will be 0. What are the forces acting? The two forces are tension and its weight. So if we take the sum, that would be T minus mg is equivalent to 0 because the object is at rest. So this gives us T equals to mg. So if an object is hanging or is at rest, the tension it experiences or it experiences will be the same as the weight it has. That is T equals to ma. But in the other condition, we are still dealing with a single rope supporting objects. Now this is one. The second thing can be the object is being supported by a rope. But then, like, let's use an elevator. If the elevator is accelerating downwards, let's see what happens to the weight of those passengers or those people inside the elevator. This is the tension, this is the weight of the object, and then we are told the object accelerates downward. We will still use Newton's laws, which as a sum of forces is equivalent to ma. What's the direction of acceleration of this object? It is vertically downward, so it means mass and acceleration will be negative, because a negative number times a positive value will always be a negative. So this gives us the tension, again we are taking the sum, minus mg is equivalent to minus ma. So T is equivalent to minus ma plus mg. You will notice that the mass is the same, so we can factor it out. So this gives us T, which this can also be translated as T equivalent to mg minus ma, or T equals to m into g minus a. So you will notice that when an elevator is accelerating downwards or is descending, the passengers will always experience a lesser weight. And that weight that they experience at that instant, it is what we call the apparent weight. Is that understood? Because the weight, there is something being taken out of the weight, that is why they seem to be at a very smaller weight. And this weight is what we call an apparent weight. The apparent weight will be greater if the elevator accelerates upwards, because the weight of the object will be supported by an external force. I think I've explained those ones. But then if the accelerator or the elevator is at rest, the weight wouldn't change. Passengers will experience their normal weight. Do you understand? You should be able to differentiate between these 3 points. If the object is at rest, the weight of the passengers will be the same. If the elevator is descending with an acceleration, then what will happen? The weight of those passengers will also be reduced. But then if it decelerates at a constant speed, remember the acceleration will be 0, their weight will also be the same. Understood? Let's take the third case. Let's assume that the elevator is moving vertically upwards. That's the direction of acceleration. This is mg, and that's the tension. We will take Newton's law. Sum of forces equals to ma. The forces are T minus mg, which is equivalent to ma, and T becomes ma plus mg. And you've seen why I said the weight will be greater when the elevator accelerates vertically upward, because their weight is now being supported by an external force, ma. Clear? Good. Now that is all for a single rope supporting an object. But then if the ropes are more than one, you will need to use different methods. And the most famous method is the resolution of forces. And when you talk about resolution of forces, you should know there should be an angle in between these two forces. And the forces in this case are just the tensions. T1 and T2 are just the tensions. But then the other thing you need to know that is in this case, the object will be in equilibrium. That is, the acceleration will be 0. And, that is it. Now, let's see this problem. We are told an object of mass m. An object of mass m is being supported by 2 ropes, T1 and T2. And the question says we calculate the total forces acting on the object. So all you need to do, the first step is to to try and resolve these forces into their into components. We will do that. Let me use a different color. Okay. This is what happens. You always extend this to obtain a triangle, a right angle triangle. That's not a good diagram. Let's take it again. You have M. You have T1. You also have T2. They are both supporting the same object. So all you do is to, this gives us, see the direction of T1 of X, and this gives us the direction of T1 of Y. We do the same thing with the other tension. This will be the direction of T2 of X, and this direction of T1 of Y is the same as T2 of Y. Good. Now, if this is extracted, you will notice that the sum of forces on X will be 0, and also the sum of forces on Y will also be 0. Now, let's identify the forces acting on the X-axis. The forces are, for T1, we have T1 of X, which is to the left, so we give it a negative sign, plus, because we are taking the sum, and the other force will be positive, because that's the arrowhead, which points to the right. That's T2 of X, which is equivalent to 0, because we are dealing with static equilibrium, where A is 0 in both directions. So this gives us T1 of X is equivalent to minus T1 of X is equivalent to minus T2 of X, and that simplifies to T1 of X equivalent to T2 of X. So these are the forces acting on the X-axis. If the magnitude of T1 is known, you will notice that it will be the same as that of T2. Good. We deal with the forces in the Y-axis. Sum of forces in the Y will also be 0, because the static equilibrium, both axes will have an acceleration of 0. The forces in the Y-axis, that's T1 of Y and T2 of Y, and if you notice, they are all pointing in the same direction. So we give them a similar sign, and that will be T1 of Y plus T2 of Y. What other force is acting on this mass is the weight, which is vertically down, minus mg of Y is 0. And this will be T1 of Y plus T2 of Y is equivalent to mg. Good. Okay, it is shown, and we've already done the derivation. We move on. Now let's see this problem. Where is it? We are told that the tensions act at an angle theta. They are acting now at an angle theta, where T1 is not equivalent to T2. T1 is not equals to T2. So we have to note something. The first thing you do is to resolve T1 of X and Y. Also, you do the same thing for T2. Or in simple language, we resolve the tension 1 into its components, that is T1 of X and T2 of X, since the angle is known. We do the same thing for T2. Now, in resolving these forces, you need to extract each triangle and deal with them separately. This is T1. The direction matters. This is T1 of X, and this is T1 of Y. And that's the angle theta. Here is just a right angle triangle. Good. So we will use trigonometric ratios again. We have sine theta is equivalent to the opposite over the hypotenuse. That gives us minus, because this is to the left. Look at the arrowhead. This gives us minus T1 of x all over T1. And therefore, T1 of x will be equivalent to minus T1 times sine theta of 1. That's the magnitude of T1 of x. And T1 of y will be T1 times the cosine of theta 1. We do the same thing for the second tension. You extract the triangle as it appears on the diagram. This will be T2 of x. This is T2 of y, and that's T2, that's angle theta 2. So we use sine theta 2 is equivalent to T2 of x all over T2. So T2 of x is equivalent to T2 sine theta 2, and obviously T2 of y will be T2 of cosine of theta 2. But a while ago, I wrote something like T1 of x is equivalent to T2 of x. But then we know what T1 of x and T2 of x are. We can substitute them into this equation. And this gives us T1 of x is minus T1 of x is minus T1 sine theta 1, which is equivalent to T2 of x sine theta 2. Good. And sum of forces in the y, we also had something like T1 of y plus T2 of y is equivalent to mg. So this will be T1 cosine of theta 1 plus T2 cosine of theta 2 is equivalent to mg. If the values of theta 1, theta 2 and the mass is known, then the tensions T1 and T2 will be found easily. Okay, this is just the absolute value we're taking, and this will be positive. So look at the question here. We are told the tension T1 in the rope is 68 Newton, theta 1 is 55 Newton. We are asked to find the x component. That is simple, you should be able to do that. The y component, you can do that. Yes, this is what I am interested in, to calculate the magnitudes of T1 and T2. Can we do that? We know theta 1. This is already copied, so I can take it off. So if T1 sine theta 1 is equivalent to T2 sine theta 2, therefore T1 will be equivalent to T2 sine theta 2 all over sine theta 1, where theta 1 is given as 50 degrees, theta 2 20 degrees, m is given as 8 kg, g is 10 meters per second. We can call this equation star. The second equation says T1 of y plus T2 of y is equivalent to mg. So T1 cosine of theta 1 plus T2 cosine of theta 2 is equivalent to mg. We can make T1 or T2 the subject. Let's make T2 the subject. This gives us T2 cosine of theta 2 is equivalent to mg minus T1 cosine of theta 1. But in T1 we are told, but T1 is equivalent to T2 sine theta 2 all over sine theta 1. T1 will be T2, we don't know, sine theta 2, where theta 2 is 20 degrees and theta 1 is 50 degrees. So T1 will be equivalent to, can we simplify that? Sine 20 divided by sine 50, that's 0.4465 T2. That's theta 1. So in place of theta 1, I will just write 0.4465 T2, and that gives us T2 cosine of theta 2 is equivalent to mg minus T1, where T1 is 0.4465 theta 2. Then cosine of theta 1. Good? The diagram is going to... Okay, a special case is when the angles are the same. If the angles are the same, it's simple. We wouldn't face all of this trouble. Now let me just try that case with you. If theta 1 and theta 2 are the same, but then the tensions differ. This is a special case. That is when L1 is equivalent to L2. This implies that T1 is equivalent to T2. Theta 1 is also equivalent to theta 2. All you do is simplify what is given. The lines have to be the same, and they're supporting the same mass. The angle is the same, so we just give it a name theta. This is T, this is T. You will notice that the sum of forces will be, on the x-axis will be T1 Tx, T1 of x plus T2 of x, where, and this whole thing will be 0. This whole thing will be 0. This is T1 of x, this direction, and that direction, T2 of x. But then T1 is equivalent to T2. So T1 is the same as T2. We don't give it an initial. And this becomes the sum of forces in the x-axis, which is, this is a special case like I said before, because the two lengths are equal. L1 is equivalent to L2, and since L1 is equivalent to L2, the tensions in L1 and L2 must be equal to each other, and the angle of inclination must also be equal. Good. Now we'll be looking at the forces in the x-axis. We know these are the forces acting. If you have to observe the direction always. You know, one points to the right and the other points to the left. So it means the sum of forces in the x-axis must be equivalent to 0. And when that happens, it will be T1 of x minus T2 of x is equivalent to 0. And that simplifies to T1 of x equivalent to T2 of x, where T1 is equivalent to T2. I think that part is understood. But then we focus our attention to the y forces, the forces acting on the y-axis. If this is resolved, we will have something like both x T1 of y and T2 of y are vertically upwards. So if we resolve this the triangle, we will have the sum of forces in the y direction is always equivalent to 0. We are dealing with static equilibrium. Remember that all the time. So this gives us T1 of y plus T2 of y minus the gravitational force, which is the weight, is always equivalent to 0. But again, T1 is the same as T2, so we don't give it an initial, we just call it T. And this will be Ty plus Ty minus mg is 0, is equivalent to 0. If you recall, we solved T1 of y as, or Ty as, T cosine of theta plus T cosine of theta minus mg is 0. So T plus T will obviously give us 2T cosine of theta is equivalent to mg. If the tension is required, we can always do that by, dividing everything by 2 cosine of theta. 2 cosine of theta. And that means the tension force will be equivalent to mg all over 2 cosine of theta. This is only true if the tensions are equal, or if the angles between them are equal, or the length of the strings or the ropes are equal. Please take note of that. Good. That is it. Good. Now we are given a question. It says a mass M is suspended from 2 massless strings of an equal length as shown below. The tension force in each string is, you give the answer. We move to the last slide. Okay. I think that brings us to the end of today's episode, and I believe these are try questions that you're going to enjoy. Try and solve them, and please get back to me, and I'll be glad to verify your answers. See you another time.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
يكسب الورق ما بت البلاد لا بشر أنت ولا مطغة ولا علق مطهر مؤمليا بمرحة سبيل